Welcome to the Microchip Is podcast. Join your host, Mike Maynard, as he learns about the technologies, products, and people that make microchip technology what it is today.
Welcome to the Microchip Is podcast. Today, I'm learning about microchip in security. I'm talking to Xavier Bignalet, who's the product marketing manager for security at Microchip Technology. Welcome to the podcast, Xavier.
Yeah, thank you, Mike. Thank you for having me.
It's great to have you on. I'm really interested to learn a bit about security. So can you start off maybe by telling me a little bit about your role at Microchip?
Yeah, absolutely. So I'm one of the product marketing managers. So I drive a few product line around the crypto authentication family. The market calls that secure element. It's a device that consists in secure key storage, crypto accelerator. We also offer secure key provisioning service. So that's the lines that I'm in charge of. On top of that, I drive the business development in the America, and I'm also in charge of taking that type of technology to the masses. We call that the mass market. So that's what I do at Microchip.
Sounds a lot there that you've got to do, and I'm certainly going to ask questions about some of the products. But before we start about this, maybe let's try and understand what's happening in the market and what's driving the demand for security. So, I mean, presumably with more and more connected devices, that's what's pushing this demand for more and more security products. Is that right?
Partially. That's what we, the security experts, were warning the market, the connectivity market, because it was about 6+ years ago. We said, hey, more connectivity, more devices, more backdoors. So yes, it is driving the market. But what has happened in the recent years, if you take security by markets, really, the key markets, so data center, automotive, consumer, and industrial, and even medical there, the communities, the embedded communities and the IT communities have came to realization that security needs to be looked at a lot more closely. And that's a very typical pattern that we see, right? You connect something and you say, oh, I need to secure it. And there's a gap of a couple of years in between. If you look at any new wireless connectivity that goes out there, the communities focus on perfecting the communication protocol itself. And when they're pushing data, they're encrypting data through that channel, they say, okay, let's take care about security. A security expert like, hey, would like to be involved sooner, but historically the comms are taken care of, then you see security. So what has happened among those 5 segments that I mentioned, standards have been popping up among data center, automotive, consumer, industrial, medical, and some of the standards have been looked up by governmental agencies to eventually turn them into regulations. So both connectivity standards, framework, and regulation is really what's driving the demand for security right now.
And that's interesting. Presumably, what each industry or application is trying to do is slightly different. You talk about automotive. I mean, presumably it's all about preventing accidents, protecting the person. Whereas in the data center, is it much more about protecting the data center itself? I mean, are there different requirements, and does that lead to different standards, or do the same solutions work?
Yeah, you have the answer in your question there, Mike. Take at the data center themselves, they're worried about how the system could be in the data center, could be tampered with, but also, well, consequently, can be trusted right at the very source, right? So if you look at the Open Compute project, they have a pretty good definition, a very good definition actually, of what needs to be taken care of. So one of their heavy focus, they have a couple of them, but one of the heavy one is secure boot, right? When you boot your main processor that runs the server, they want to make sure the image is as genuine as possible. So there are products in the bill of material that needs to be within the data center. And my group actually offer one of those platform of trust that's mentioned there. There are many other practices. That's the one I'm intimately familiar with. I would call that local security for the data center. And if you try to understand why they do that, on security, all has to do with the value of the assets you're trying to protect. And based on that, you have a list of security measures, practices, devices, type of security devices that you'll be implementing in your solution. So obviously, data center in the world of today is probably the most sensitive environment, right? So that's why they do that. And then you have the world of automotive. And every time I say the word automotive, I have the word industrial in my security mind. So what the automotive experts are focusing on is really safety, right? And now you got that parallel that you have to draw between safety and security. So you have ISO 26262, I think, is the safety standard, and ISO 21434 is the security standard, both for automotive, right? So the debate in industry is how do you start to take practices of both and start to merge them? Because if you take the ISO level in automotive, it's how critical the situation is with regards to the vehicle and the people in the vehicle, right? So could be just blew a tire or there's a fatal accident that has happened, and how the electronics needs to react and help mitigate the situation, those type of situation. So you still see some, I'll call that some type of disparity in the automotive market. The industrial guys, the way they were thinking, they actually, my very personal opinion, based on what I learned and read on each of the standards, they made an effort. They haven't tried. They made an effort to start merging safety and security. I would argue a little bit better. They have one of the good example is the IEC 62443, where their philosophy is the safety of the person, obviously, the safety of the environment. So take the big scary example, the nuclear plant, right? Now you have people in that nuclear plant, something really bad happened. When it's really bad, it's really, really bad, right, in that environment. So measures have to be taken spontaneously. Now you have the notion of real-time operation with security coming in. Security historically didn't necessarily have the notion of real time. So one of our partner, I'll call them out, Security Pattern. They're based in Italy. They're specialized on 62443. What they were teaching me is, in the world of payment, if you go to the grocery store, you swipe your credit card once, it doesn't work. Swipe it twice, doesn't work. Swipe it 3 times. In the US, they will be okay. Plug in the chip. So you don't have that notion of real time like you need in a nuclear plant, right? That machine needs to stop immediately. If not, the operator could be in danger, right? So 6243 is what's defined to address that stuff. So you see the difference of approaches. The data center is more that local security in the data center with regard to the OCP standards. You have automotive industrial. They're trying to get the same view of handling safety and security really for the benefit of the person, the infrastructure, and use the right technology to achieve that. And then you have the world of IoT. IoT is really, I think it's the consumer market, the privacy of the users, the protection of the users. Europe has been a massive driver for that. And I think they're pulling the rest of the world. I mean, you see a lot of the countries are following or getting inspired by. So anything connected, back to your point, right, has some type of backdoors. And I say some type to be very vague. You have to identify your threat model and decide what your system should be using. And then the medical market is following really what the consumers are doing, because that's really the motion is you have those medical devices going from the hospital or doctor's office into the patient's house. So really kind of become a consumer product there. So that I'm trying to make sure I didn't forget anything, but that covers the landscape of segments versus standards and how they approach things a little bit differently.
It's fascinating they approach things differently because, as I understand it, it's very much the same sort of functionality and the same type of products that you need to achieve these goals across the different markets. Is that correct?
Yes to the first half of your question, no to the second half. Yes, philosophically, it's the practices are awfully similar. We talk about use cases in the world of security. You're going to have your secure boot to make sure the code you boot from is genuine. When that's running, your system is up and running, right? What is your system going to do? Is it going to connect to a cloud infrastructure or not? So if you look at the data center, that's the cloud. You're within the cloud already. So there's no connection to the cloud. But when the processor is up and running, he's going to talk to a bunch of other embedded system. And then you have the notion of local authentication from the processor to the surrounding ecosystems there. So you have the notion of building a trusted ecosystem of hardware within the data center. But philosophically, when you have an IoT device, you want to trust the connection to the cloud, and cloud wants to trust the connection to the embedded device. So you get your secure boot, your connection to the outside world. I'm going to keep it there. And then once you have that connection, you probably want to update your code because there's bugs, there are vulnerabilities that are coming. So now you have the notion of updating your firmware either locally or remotely, right? And those would be probably the three most important foundation for an embedded system. Then you get into the notion of user access privilege. What type of user has what type of privilege? What type of user can do what into your embedded system, in the data center, in the car, in your robot, in your factory, in your medical system that you took from the doctor to your house, in your thermostat. So those practices, yes, they're common from one industry to the other. You also ask the type of device are very different now, very, very different, because the complexity, the horsepower, the memory requirements, the power requirements are very different from a data center to a battery powered consumer device. And that's where things become really difficult, and segment experts on security would be very different from one segment expert to the others. If you put a guy that, and I'll speak by experience, we work with experts from the data center. They have a ton of horsepower, a ton of resources. So they can do a lot of advanced use cases in the world of security. If you end up with a tiny consumer device that connects to the cloud and that's battery powered, your resources, so your compute power, your memory, your power requirements are extremely reduced, right? Yet it still is a backdoor to a cloud platform. So that's where the diversity in terms of type of product comes in.
So that's interesting. You've got multiple functions and you've got very different environments for the different applications. I mean, does that lead to Microchip having to produce a large number of products, or do you tend to integrate functions into a single product? Can you give me a little bit of an overview of your product families for security?
Yeah, absolutely. So it's strategy really at that point. And there's been a lot of Microchip Is podcasts that to encourage everyone to listen to all of them, because you're gonna listen my peer talking about FPGA, for example. I remember Dan talking about that recently. So an FPGA would have their target segments. The FPGA is not going to fit necessarily everywhere. And the horsepower they have accessible to the inside the chip is pretty advanced compared to a Cortex M23, for example, trust zone enabled microcontroller. Very different space. So what we do at Microchip, we have a pretty wide portfolio of solution that we offer enough versatility among our, M0s, M23, M33. Then you go into the M7, we go into the A5, A7s, and then we switch to the FPGA. I'm trying to make sure I don't forget anybody. So that's for all the microcontroller side of things. So if you take the microcontroller, microprocessor, FPGA, really what's in there, I'll start with a trusted execution environment. That's the big buzzword out there in the industry. I think all of our lines of microcontroller processor and at least the 32-bit micro, the microprocessor and the FPGA have that notion of trusted execution environment. What this is, it's just an isolated memory zone where you'll need rights and permission to access and do things within and load things in within. So for example, the M23 is just a very small zone, and it's one zone. You take the FPGA on the other side of the spectrum, I think they have 16 zones that they have right and permission to load things and do things from a crypto standpoint, from a security standpoint. If you put trusted execution environment aside, there are more simplistic notions that our controllers are doing. You still have the notion of basic rights to access an OTP. There's no secure storage there, but there's notion of permissions to access the OTP to write within, to write the keys or so forth. So physically, you'll be able to attack it. Is the physical attack a concern to you? Yes, no, then you take a decision on that product. That's for the controller side of things. So we have a line of wireless that has all the standard communication, and that's something we preach is use what's standards in the world of communication. So Bluetooth, Wi-Fi, LoRa, those type of things, because they are consortium, backing up the protocol. and testing the protocol to make it more and more robust and support it. Support is a huge thing there. We have those standalone devices like the line that I support, the crypto authentication, crypto automotives, the automotive version of it. Those are standalone security storage with the crypto accelerators, and we have those platform root of trust IC. So you can see the breadth of devices because that security puzzle, Microchip is doing its best to address as many markets as possible, as many different type of engineer as possible that lives within those markets. So you need that big puzzle to satisfy, the end customers, again, in data center, medical, automotive, industrial, consumer. We offer that breadth of portfolio.
And it's fascinating because, I mean, you mentioned you have standalone products, but it seems like a lot of your work is actually helping build in security into FPGAs and MCUs. So you must work a lot with some of the other business units at Microchip.
Absolutely. Absolutely. We have, there has been for a couple of years a strong initiative to build what we call this total system solution, where the idea is to put the best embedded puzzle together for a given application of a certain market. And if you look on our website, we do that all across, not just in security, but all across the applications. Yeah.
I love this concept of total system solutions, and you're not the first person in the podcast to mention it. It seems Microchip is, I think, almost unique in the way that different business units very openly work with each other to make each other successful rather than having some sort of internal competition. Do you think that's fair?
Absolutely. Or yeah, it's in executive guidance. They have, if you look throughout the past several years, I don't know how far we can go back, but I remember that there's a tremendous amount of acquisition. Microchip is known for that. So to make that work, we as a community in Microchip have to work together and put our technologies together. So you have a lot of employees coming from different companies that become Microchip, right? And the synergy is pretty powerful. If you look at the employee profile, a lot of us have been there for many, many years. I'm attacking my, I think, 9th year here, going on 10 next year. And I'm probably still one of the youngest employees. So this is a culture they're building. We talk about TSS and making sure the tech works, but what goes beyond it is the culture of Microchip of bringing not only the technology, but the people together. Bring the people together, will bring the technology together. If you have the silo, that doesn't work, it doesn't sell, the revenue doesn't come.
I love it. I think it's something, I'm more and more finding out about Microchip every time I talk to people. It's all about collaboration. I mean, I think one of the other things, Microchip is really well known for is providing support for people to actually use the technology that you create. And it must be a big challenge in security where potentially you've got customers who a few years ago had very limited requirements in terms of security and now are seeing, with increased connectivity, increased regulation, standardization, a massive change in what they have to do. So how hard is it for those customers and what are you doing to help them?
It's been very challenging. If we listen again to everything we talked about, you had a pretty significant portfolio that integrates complex security functions. And how do you use them, right? And how do you put all those chips involved with security all together to make sure it works and address a certain use case for a certain segment? That's not trivial. What we've done at Microchip within our tools, so that is MPLab, Harmony, Melody, the Trust Platform Design Suite is the tool we use in my business units here. The idea is to first teach the customer what the use case is and what problem is solved. So we take the customer through an education phase via the tool. So we start with the concept of, I'll speak for my product line as I know intimately what's in there. We take the customer from, hey, here's my host, here's my client, this is the use case you're achieving. We actually deliver what we call a transaction diagram that will address a certain threat. And we said, this is the threat you can address, nothing else with this thing. And we go into the next use case, next use case, we walk them through this education phase there. Once the theory of the education is complete, we actually the tool, walk them step by step. So we click through a bunch of steps so that they execute that use case and get a feel for it. They start to touch the use case to have the user gaining more confidence of what they're doing. And we point them to relevant libraries. And with the libraries, we're teaching them again. It's a lot of teaching what those API calls are doing, what the secure element will be doing. Once you're done with that, we actually deliver a turnkey code examples. Like, okay, you want to play with the same use case in the microcontroller. Here's the code examples, deliver everything. Once that's done, we deliver them different options to load the keys into our secure element using the Microchip service, the Microchip provisioning service. Or we just launched recently what we call the Trust Manager. It's powered by Keystream from Kulowski. So it's a software service-based in-field provisioning solution into our secure element. So you see, we guide them through that journey step by step. Start with education, always, always. You're going to see a tremendous presence of our content on YouTube, and not just marketing content, but tutorial type of content, implementation type of content, so that our customer can consume that technology without necessarily having us on the phone.
I love that. And I think integrating that education into the tools is a great idea, because that's obviously going to help people have a much better experience as they first start implementing security. And presumably it's something that people can still use during the configuration phase as they get more experience too.
Yeah, absolutely. No, you're absolutely right. Yeah.
I'm aware of your time. I know you're very busy, Xavier. So just to finish off, I've got a couple of more general questions. I mean, one is, if you have customers coming to you, saying that they're under pressure, they've got to do something about the security of their product. Do you have, one bit of engineering advice you can give to people as to how they can start going about understanding what they need to do and then implementing it?
Yeah, no, absolutely. Absolutely. It's start with your threat model. If you come with a question, say, I need help with security, before you even ask that type of question, you got to consider a threat model. So what is a threat model? Sounds like a crazy name for something that's not that hard. You would take your product and start listing every problem from a security angle that you think will happen to your product. Nothing is bulletproof. Nothing is bulletproof. So you got to be thoroughly honest and self-critic with your own product. And then you rank those problems with a level of impact and risk, right? In a nutshell, that's building your threat model. That's the theory. The practice is really because of, in all honesty, we run a security product line. We deal with that too. You do have engineering ego that's going to come in, and yet you have to be humble with this analysis. That's extremely critical. That's the beginning of everything. So in the industry, there's a market for third-party companies. So we like to work with Kulowski, for example, as one of the company we like to recommend to our customers. They would come in and decompose your system from a security standpoint, and they'll tell you the type of vulnerability they think you'll be dealing with, and that gives you an opportunity to fix it before you launch your product, right? So then there you go. Now you start to go into the development plan. You start to prevent instead of correcting. Correcting can be very, very taxing. And that leads me to maybe this here. If you look at the statement in the European regulations that are about to hit us, if they hit us, the Europeans are saying the first 5 years of the life cycle of your device for an IoT to sell an IoT product in Europe, you're going to have to be to patch any vulnerability coming in the first 5 years. You have no idea of what that vulnerability tomorrow is going to be. So if you don't do your threat model, that's going to be extremely taxing for those IoT products in the European market to be corrected. Extremely taxing. So do the right things up front. We've said that for years. We'll continue to do it for years.
I love that. That's fantastic advice, and certainly something I think is going to save a lot of people a lot of pain in the future. And it feels like you've covered a huge amount, Xavier, from the applications, the functionality, the products. I mean, what is the one thing you'd like people to take away from this podcast and really remember about microchip insecurity?
It's a very good question, this one. The main takeaway would be call us. Call us. And the reason is Microchip has put an infrastructure in place of people, facilities, manufacturing to address the diversity of type of accounts, of segments all across the world. Microchip is focusing on that diversity. So we'll be here to support you. Our support structure is probably a game in the semiconductor industry. with security in mind, we have shaped our sales organization to have a technical branch of many experts all across the world that are here to back up this technical support that we offer all across the place. Well, you see from other semiconductor companies, the typical way to run business is high volume account, big support. The rest gets little to nothing. We do support the large accounts, but we are shaped to address the masses. So call us.
That's fantastic. And if people want to get hold of you, where would they get that number from, and how would they find out more?
Now, the best way is really to contact your local Microchip sales office. We have security experts plugged into each sales office across the world, literally. So call your local sales manager there. He has a security expert right in his regions, and that's how we are structured all over the world.
That's fantastic. Xavier, I really appreciate this. I feel I know a lot more about what Microchip is in security. Thank you very much for your time.
Thank you, Mike. It was a pleasure.
Thanks for listening to the Microchip Is podcast. Please follow us on your favorite podcast platform to keep learning about the many technologies, products, and people that make Microchip what it is today. Look out for our upcoming Microchip Is podcasts and our new Beyond the Microchip podcast series.